Hello and welcome. Today, we're going to explore a fascinating technique called diffuse reflectance spectroscopy. It might sound a bit technical, but it's actually a very clever way to analyze materials, especially things that are powders or have rough surfaces, without having to do much to them first. So, what is it? Let's start with a simple idea. Imagine you shine a flashlight on a mirror. The light bounces off in one predictable direction. That's called specular reflection. Now, imagine you shine that same flashlight on a pile of white sugar or a matte white wall. The light doesn't just bounce off the surface, it actually enters the material a tiny bit, scatters around inside between all the little particles, and then comes out in all directions. This messy, scattered light is called diffuse reflectance, and that's exactly what this technique measures. The process works in a few key steps. First, we shine a control beam of light, containing a whole spectrum of colors or wavelengths, onto our sample. Second, as this light hits the sample, like a powder packed into a small cup, it penetrates the surface and begins to scatter. Third, and this is the most important part, as the light bounces around between the grains of the powder, the material will absorb very specific colors of light based on its chemical makeup. The colors that are not absorbed are the ones that continue to scatter and eventually exit the sample. Fourth, we collect all of this scattered light coming out in every direction using a special device, typically an integrating sphere, which is basically a hollow sphere coated with a highly reflective white material. Finally, a detector measures how much light at each specific color made it out. By comparing the spectrum of the scattered light from our sample to the light from a perfectly white, non-absorbing reference material, we can figure out exactly which colors were absorbed. This absorption pattern acts like a unique fingerprint for the material, allowing us to identify its chemical composition, determine its color properties, or even measure the concentration of certain substances. It's incredibly useful in fields like materials science for analyzing catalysts and pigments, in geology for identifying minerals, and in the pharmaceutical industry for checking the purity of powdered drugs. Thank you so much for watching this explanation. If you found this video helpful and want to learn more about scientific techniques, please consider supporting the channel by liking this video, subscribing, or leaving a question in the comments below. Your engagement makes a huge difference and allows us to keep making more content. We'll see you in the next one.